G'day chemistry students, in this video we're looking at dot point 8.1.4. Our aim is to look at the steps required to make a calibration curve in a school lab and figure out the concentration of a contaminant in an unknown sample. Let's get into it. So to do this, we are following a process called colorimetry. Generally, you can undertake colorimetry using a UV-Vis spectrophotometer. School ones usually look something like that. Again, all the interworkings are on the inside. You'll notice that there's a little hole here for a space for a container for the sample, but that's about all you get to see from the outside. Similar processes can be done to undertake colorimetry for AAS spectrometers, but they're significantly larger and much more expensive, so we won't be doing that in the school lab. So the first step for colorimetry is to make a series of solutions that have known concentrations. And they need to have the chemical or the ion which you're analyzing. So for example, if you are trying to analyze the concentration of copper in an environmental sample, then you need to be making copper solutions, different concentrations. Generally, the best way to do that is to make a stock solution of the exact concentration that you want and then perform a series of dilutions. What you then need to do is figure out an appropriate wavelength to actually use to make the calibration curve. So generally what that means is you'll put one of your standard copper solutions into the spectrometer, figure out what wavelengths absorb best. In this example here, we can see that the wavelength's being absorbed pretty highly at about 470, and that's what you would set your spectrometer to be emitting for the rest of the tests. So then you'll set the spectrometer to your selected wavelength, we set about 470, and take a blank. So you'll put in a cuvette, the container that actually holds your sample, and just fill it up with the solvent that you use. So in most cases, in almost all cases actually, that would be water. So you'll put it in and take your blank. That'll mean that any air that the light's passing through, the cuvette that they're passing through, and the solvent are all taken into account before you actually take a measurement of the absorbance of the substance. You can then take the solutions and put them in and start to take measurements and plot that absorbance against the concentration of the standard and dilutions that you made beforehand. From that, you can construct a line of best fit, and that's your calibration curve done. If you're plotting it onto a spreadsheet, you should also get your y equals mx plus b formula. You can use that formula to calculate a concentration really accurately. Next thing that you need to do is put the sample in and record the absorbance of that. Based on the absorbance, your y value, you can then determine the x value, the concentration. And that's pretty much it. It's one of those things too, where once you understand exactly what's going on, it's super simple to do, and really easy to apply your skills to a variety of contexts and situations. Thank you very much, everyone. In the next video, we're going to be looking at iron 3 thiocyanate and the equilibrium that exists there. It actually harkens back to a dot point all the way back from Module 5. But to do the experiment outline in Module 5, you need to have an understanding of colorimetry to do it properly. So we'll have a look at what that's all about and try to get it done in the lab as well.